The first thing to do is just transfer the liver from the container to the beaker. Okay, it's been frozen, so it's fairly soft tissue at this point. As long as you transfer most of it. And then we should do a bit of chopping. We take the scissors and then stay on ice or as close to the ice as possible and chop it, 30 times or so. It's not bad. And then we have the homogenization medium. It's transferred to your beaker. Mix a bit to resuspend. What you do is there's always a bit left behind, so allow the pieces to settle within the homogenizer. And take a bit of the supernatant, bring it back to the beaker, and resuspend. And back in. You homogenize, always keep on ice, introduce the piston, and what you want to do is actually force the liquid in between the glass and the Teflon. And since the environment is isotonic, we're not causing any sort of chemical lysis of the cell. It's going to be mechanical, because this will be a high pressure zone, and this will cause the lysis of the membranes and liberate the microsomes, the mitochondria, and nucleons. So at this point, close to the tissue, and it gets very dry, so you need to go back and bounce on it a bit. And with the tissue in, sometimes it's just direct pressure and wobble the piston, and you can see now the connective tissue moving in between Teflon and glass. That's your high pressure zone, and that's where your tissue will get lysed. And you keep doing this until you're at the bottom. When you do reach the bottom of the vessel, or the glass part, that actually counts as your first pass. So there's next to nothing left in here. A lot of tissues or membranes over here. So what you want to do is withdraw, and always use a wobbling motion, and it allows the liquid to go back in between glass and Teflon. Initially it's a lot of resistance because it's fairly viscous. Back to the top. Avoid a lot of gargling. Back down. And now it's easy. Now we need to transfer the Corex tube. It's about 10 mils. Okay. At this point we're ready to centrifuge.